Hello friends, I Professor Thakur from Terna Engineering College Dharashiv welcomes you on my YouTube channel for this subject head digital communication. Friends, as far as our today's session is concerned, so we will try to learn the significance of this PN sequence or the pseudo noise sequence which is used in case of this spread spectrum modulation technique. Because as far as this spread spectrum modulation technique is concerned, so we are very much aware of this thing. The objective behind this spread spectrum modulation is to enhance the bandwidth of this proposed transmitted signal as compared to the bandwidth of this input signal. So this spectrum spreading is to be done with the help of this deterministic sequence, or we can call it as a periodic sequence, whose name is nothing but the pseudo noise sequence, or most of the time that can be called it as a PN sequence. So in this session we will try to learn how this sequence is being generated with the help of this structural diagram or with the help of this functioning diagram, and along with this description we will try to learn the few important properties of this PN sequence adopted by either the analog spread spectrum technique or the digital spread spectrum technique, because already we had discussed the analog type of spread spectrum technique as well as the digital type of spread spectrum technique in our previous session. So let us quickly go through the PN sequence generator basically, right? Now as we can call it as a generator, so which consists of these four identical blocks, right? So here each and every block stands for what, or we can call it as a shift registers. 4 shift registers we used to have with us. The function allocated to this shift register is to store the element within that shift register, right? And along with this 4 shift register we used to have one type of mod 2 adder, right? So here mod 2 addition means what? As far as the basic logic gates are concerned, so this modulo 2 addition is nothing but what? It is just similar to the exclusively OR operation. If we do have with us the 2 input OR gate, right? So if suppose A and B, these two are the inputs of this OR gate, so 0 0 0 1 1 0 and 1 1. Now XOR or the exclusively OR operation, when both inputs are same, so obviously output is 0. Here as we do have the different inputs, so output is 1. Here again 1 1, so output is 0, right? So we need to follow this modulo 2 addition, because as far as this functional diagram or the structural diagram is concerned, so as we are having the 4 different shift registers starting from C0, C1, C2 and C3, right? So here the content of this C1 and C0 or C0, these 2 shift registers are being added with the help of this modulo 2 adder, right? Now see, such type of shift register that can be called as a linear shift register. Now one question arises in our mind, why it is being called as a linear shift register bank? Because whenever such type of shift register structure is being excited with the help of this external clock signal, or once we apply a desired clock to this 4-bit shift register, at that time what will happen? Obviously the content of each and every shift register would be changed, right? And at the same time the sum of these 2 registers C1 and C0 are being added with each other, and this particular addition is being given to the shift register called as a C3, right? So due to this fact, means we do have a certain type of feedback, as well as once we apply the every clock, the contents of this each and every shift register would be shifted with each other. So that's why it is being called as a linear shift register bank. So our objective is to know how the desired PN sequence or the spreading sequence is being generated with the help of such type of linear shift register structure for the purpose of spread spectrum, because the spectrum spreading is to be done with the help of this spreading sequence only, right? That is the basic logic behind this spread spectrum modulation technique, right? So in order to understand the working phenomena of this structural diagram with the help of this tabular method, first of all what we need to do here, first of all we need to assume the contents of each and every shift register, right? Now according to our own convenience, we can assume the contents of these 4 shift registers, any value apart from this value, which is nothing but what? The 4 times 0, right? if initially the contents of each and every shift registers are equals to 0 once we apply a certain external clock signal. So at that time it is not possible for V people to come out of this one type of loop, because once we set each and every shift registers towards the 0, right, even though we apply the next clock pulse, what will happen, right? If suppose this is C3, C2, C1 and C0, right? Before applying the second clock pulse, the contents of these two shift registers are being added with each other. So 0, 0 equals to what? Obviously, when both inputs are low, or when both inputs are same, the output is 0, right? So C1 plus C0, which exclusively OR operation in between C1 and C0 equals to 0. This 0 is being shifted to this C3. And meanwhile, C3, the content of C3 is being shifted into C2, content of C2 is being shifted into C1, and C1 is being shifted into C0. So initially, if all zeros are present, so it is not possible for we people to generate the desired symbol sequence, right? So for that purpose, what we will do, after arriving the first clock pulse, if we assume the contents of this 4 shift register is like this, which consists of C3 equals to 1, C2 equals to 0, C1 equals to 0, and C0 is equals to 0, right? So as a result of applying first clock pulse, the current content of these 4 shift registers are 1 followed by 3 times 0, right? Now see, as these are the linear shift registers, so whenever we apply the second clock pulse, so at that time first these two bits are being added with each other in terms of this mod 2 operation, as well as the content of remaining shift registers are being exchanged with each other. So as a result of this here, C1 XOR of C0, obviously it will become 0, and these 3 bits, the C3 is being shifted into C2, C2 is being shifted into C1, and C1 is being shifted into C0. So as a result of shifting, it will become 1, 0, 0, right? Now again, as a result of exciting third clock pulse, these two bits are being added with each other in terms of exclusively OR operation. So it will become 0 XOR of 0, it will become 0, and these 3 bits are being shifted 0, 1, 0. Now this is the result of third clock pulse. In same manner, fourth clock pulse, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, right? When we apply the clock number 16, at that time what will happen, carefully we need to understand, the content of this shift register will remain same, right? Means once after 15 clock pulse, the same content will be there. The content is nothing but what? 1 followed by 3 times 0. How that content will come? Because when we apply the 15 clock pulse or the clock pulse number 15, the current status of this C3, C2, C1, C0 is nothing but what? 3 times 0 followed by 1, right? How that current status is being generated? As a result of clock pulse number 14, right? So in this clock pulse number 14, here C1 equals to 1 and C0 equals to 1, so 1 XOR of 1, it is 0, and these 3 bits are being shifted like this. So this C3 will become C2, so 0, C2 will become C1, so it will become 0, and C1 is nothing but what? C0, so it will become 1, right? Now again, when we apply the mod 2 operation in between 0 and 1, so 0 XOR of 1, obviously it is 0, and the remaining shifted bits are 0, 0 and 0. So the same code we are getting after the clock pulse number 15. So we can say that this is the periodic sequence, or we can say that this is the deterministic sequence, where the desired period of this sequence is to be tabulated with this factor 2 to the power n minus 1, right? Where n is nothing but what? The number of shift registers. Here the number of shift registers are 4, right? So 2 to the power 4 minus 1, obviously it is 13. 2 to the power 3 minus 1, so 2 to the power 3 means what? 16 minus 1, obviously it is 15, right? So this is how the PN sequence is being generated. Now the question arises, the desired PN sequence is what? Because the output is obtained across this C0, right? Output is obtained across this C0, so the desired PN sequence will look like this. Here the desired PN sequence will be what? if we collect all the bits belongs to this last column, so the Pn sequence is, here I will write 3 times 0 followed by 1, 2 times 0, 2 times 1, 0, 1, 0 followed by 4 times 1, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15, right? So this is the desired Pn sequence generated by this linear shift resistor, right? When we apply the clock number 16, the same content will be, or the same code will be generated out of these 4 shift resistors. So in this way it consists of 15 different bits. So in this way the total period is being defined. Now as far as the properties are concerned, so there are 2 important properties of this Pn sequence. Out of that 2 property, first one is nothing but what? The balance property, and the second one is nothing but what? Run property. So one by one we will try to discuss these 2 properties. Now as far as the balance property is concerned, so by taking into account this balance property, we will come to know, or this balance property will try to tell us that the total number of ones which are included in this Pn sequence are always greater than total number of 0 by an amount of 1. By the desired factor of 1, the number of ones are always greater than number of 0. So how to express this property? Very simple. The total number of ones are equals to 1 plus the total number of zeros, right? So in this way, this is the unique characteristics, or this is the unique property of this Pn sequence. Ki number of ones are greater than number of zeros by an amount of 1, right? So by taking into account this fact, as we know in this Pn sequence there are 2 symbols. One is 0 and another is nothing but what? 1. So when we put one statement here, that is nothing but what? P. So we have P of 0 and P of 1. If we are in need of, the probability belongs to this 0, or the occurrence probability of 0 and the occurrence probability of 1. When we are interested to define the occurrence probability of 0 and occurrence probability of 1. So at that time, how to get these 2 marginal probability? Very simple. When we are interested to define the marginal probability of 0, so what we need to do? We need to count how many number of zeros we used to have with us, right? Account the total number of bits which are included in this Pn sequence. So here capital N equals to what? 15. As we are having the 15 different symbols, those are being expressed in terms of 0 and in terms of 1. So in same way, how to get the occurrence probability of this symbol 1, which exactly equals to the total number of ones divided by the length of Pn sequence, right? So this is nothing but what? The balance property of this Pn sequence, or the pseudo sequence. The second property is nothing but what? The second important property is nothing but the run property of this Pn sequence. So let us quickly go through the run property of this Pn sequence, right? This is the second property, run, right? So here actually run means it indicates the length of continuous bit which are being included within this Pn sequence, right? As we are having the 15-bit Pn sequence with us, which consists of 15 different digits, right? Now carefully when we try to see, as far as the first 3 bits are concerned, the first 3 bits are nothing but what? The 3 zeros, right? So that can be called as a one run, right? Immediately whenever we are going through the signal transition, when this Pn sequence changes from either 0 to 1 or 1 to 0, that can be called as a transition. So this one itself is the second run. This is the first run, this is the second run. Then this 2 0 is nothing but what? Third run. This double 1 is nothing but what? Fourth run. This is nothing but what? The run number 5. This is run number 6, run number 7, and this is nothing but what? The run number 8. Right? So we will come to know that there are how many runs we used to have with us. So there are 8 different runs. Right? How many number of bits we used to have within this Pn sequence? There are 15 different bits. How many number of shift register we used to have to generate this 15-bit Pn sequence? There are 4 shift registers we used to have to generate this 15-bit of Pn sequence, right? So see, this run and balance, these 2 are the important properties of this Pn sequence. So this is how this Pn sequence is being generated for the purpose of spectrum spreading, in case of the spread spectrum modulation technique, right? So I just hope you had understand all these things which we are discussing in this section. Thank you.